Suppose ask you to write a program where you want to store two different pieces of information coming from the user. So the user is going to provide you with a name and an age of a person. And I ask you to store it in a very meaningful way. And what you might think about doing is you'll say, okay, well, there's lots of information, so I'm not going to store them as individual variables because there might be multiple names and ages that the user gives me. So I might end up using a list. And that's a credible solution. So what you might end up doing is you'll say, okay, I have a name list, right? And which will fill up like this. So I'll have a name, and let's have a Tom, and let's have a Harry. Right? So you'll have names here, and then right off the bat, you'll also have a list of age, the associated ages for these people. So let's do 20, 21, 22, right? So then if I ask you, okay, well, how have you stored person 1 that the user gave you? You'll say, okay, well, that's pretty easy. The way I did it is I used the indexes in these cases, because at index 0 of my name list, I will find the first person. At the index 0 of the age list, I will find the age of that person. So it pretty much works out. And then you might also come up with another solution where you'll say, okay, I'm just going to use a single list for the solution. So I'm going to say user list, and I will still attempt at storing these two informations together. You know, they're associated here. And so you'll say, okay, what I did was I made a list where I have a name and a age as an inner list for this user list. So every person has their own list with 2 elements in it, 21, and then we'll also have Harry with 22 here. So now, if in the previous list I had index 0 for these two, so associated person is at index 0. At index 1 you had Tom with his age, and at index 2 you had Harry with his age. Here things are a little bit different. So we know that if you have a list of a list, you have those outer indexes, right? So this user list currently consists of 3 different lists, and each list in itself will have its own set of indices, right? So now if I ask you, okay, can you give me the name and the age of the first person that the user gave you as input, you'll say, okay, that's pretty easy. What I'll do is I'll say that the first person is stored at index 0. And we know this will evaluate to, if I were to print this out, this will evaluate to my list here, the inner list. And so you say, okay, do you want the name? And I say, no, I want the age of that person. You'll say, okay. Well, I know that within that list, index 0 and 1 are there, so I will give you the index 1 in that case, and that will basically give you the age of the first person. And I'll say, okay, that's pretty smart. What about the third person you added? And you'll say, that's pretty easy. I'll have user, list, and index 2. So at index 2, I have the third person stored, and if I want the name of that person, I'll just pass the index 0. So I know for a fact that the user list box bracket 2 will evaluate to Harry and his age. And then this whole thing combined, so me saying give me the index 0 of that guy, of that particular list, will give me Harry. Pretty easy and trivial solution here, but here's a caveat. What if I ask you to give me the age of Harry? I'm not saying give me the age of the person who was stored last in your list, or the person who was stored in the front or in the middle. I'm saying give me the age of Harry, the person you stored. I know he's stored. So how would you work that about? Well, given this 2-list system, you might go and say, okay, what I'll do, there's a possible solution here. What I'll do is I will do namelist dot find, and I'm going to find Harry. And I know this thing gives me the index, right? And so if I store that in a variable, let's say I, and I will become 2 in this case, well, then I can just do age list index I, and that will give me the associated age for Harry. Because again, here with this 2-list system, we were hoping that the names and the ages are stored at the same indices value. So if I know the index of Harry where he's stored, then I will also know the index where his age is. But you'll notice that we have to take some extra steps here, and that's not fun. In this case, with a single list system, it's going to get harder. What you'll have to do is you're going to run a for loop inside your user list, and then for each single inner list, you're going to see if their 0th index is Harry or not. And if it is, give me the associated index 1 value. And then that's more code than these 3 lines too. So there should be an easier way, and there should be an easier way of storing information where you have more than one value associated with each other. So what I mean by that is, when you're concerned with storage of maybe a pair of values, because I want to store not only the name Rao but his age. I want to store not only the name Tom but his age, and I don't want to just store the name Harry. I also want to store his age too. So in this case, lists might not be cut out for what we're trying to do, and instead we use a new data structure, the last one we'll learn in this class, called a dictionary. Now, the way you must have heard of, the Webster dictionary, and the way it works, a dictionary works, is that you know of a set of words. So you'll have a set of words, and each of those words in the dictionary will be associated with its meaning. Right? There's going to be long text of their definition and everything like that. And the way you use a dictionary in real world is that you say, okay, I want to find the meaning of the word X, and you'll go through the dictionary and you're going to, go through pages, and you're going to find where X is, and then you're going to look up its meaning. But you're not going to do it the other way around. You're not going to say, ooh, I need to find the word associated with this meaning, and I'm going to go look for it. That's not the case. So there's always this one directional association happening, where given one piece of information, I should be able to extract the associated piece of information. Think of it as a lock, right? Given the key to the lock, I want to unlock it, right? So the way you would transition that in Python is we will use these terms as the words will become our keys and the meanings will become our values. So given the key X, give me the associated value, the meaning for it. And so in our example, we could then say that all the names are keys and all the ages are values. It's pretty simple. So let's see how they will look like if I were to use them in a dictionary. Now, the syntax is going to be a little bit different, but it's not that bizarre. So for context, I'm still going to make that list. I'm still going to make, let's say I'm going to make the name list. This for context. I'm going to have, this was Rao, you had a Tom, and then you had a Harry, right? And they had their own indices, so 0, 1, and 2. And if I needed the information at index 1, I'll get Tom out, right? That's how I do things. Well, with a dictionary, let's call it persons. A dictionary you will define in Python with curly brackets, right? So lists with box brackets, tuples with parentheses, and dictionaries with curly brackets. And you're going to have comma separated values just like a list, but you're going to have pairs separated by colons. So what you'll fill up here is you'll have a key and a value, a key and a value, a key and a value, and so on and so forth. So what you're going to do is you're going to say, I'm going to have the key Rao, and it is associated with the age 20. And I have the key Tom, and it's associated with the age 21. And I have a key Harry, and associated with the value 22. Pretty cool. Now, once persons is defined, I can very easily tell you what the age of Harry is. Now remember, using just lists was pretty hard, even with the two different solutions, but now it's going to be really easy. And it is building on how I access things in lists. So if I needed to get the index 2 value element in my list, I will do name list, and then in box brackets, I pass the index I want, right? The index here goes, and I will do 2, and that will produce the string Harry. Well, now in dictionaries, we don't actually have any indices. So what we do instead, we'll write the same setup here. We'll have the box brackets here, but instead of filling them with the index value, we'll fill them with a key value. So I will pass in Harry, and let's say I print this out, right? Let's say I print this out. What Python will see is that it's saying, oh, you want me to give you the value of key Harry in dictionary persons. That's what Python will evaluate. It'll say, okay, so you want me to get you the value of key Harry in persons dictionary. All right. And it's going to go one by one and try to find it. And it finds it. There exists the key Harry, and it will print out the age 22. Instead of using those multiple line solution when you're using lists to store, multiple information that's sort of paired together, a name of a person and the age of a person, you're just going to use a single line of code to grab that pair. So you will give, you will basically do a dictionary name, and then in box brackets, you will pass the key, and this whole thing gives you the associated value to that key. Pretty easy. So let's look at an easier dictionary here. So I'm going to define a dictionary D, and I can start off with an empty dictionary. So yes, you're very much able to add things and remove things and update things in dictionaries, so that makes them mutable. So you got to remember that. I'm just going to write down they're mutable, and we also know that there are data structures. I'm just going to write these two down. Okay, we'll look at the other properties maybe in class. But for the time being, I can start off my dictionary empty, and then I can add things to it. Or let's just, for the example right now, let's just have a dictionary where I have the letter H associated with the number 2, and the letter E associated with the number 5. And if I tell you, okay, can you give me the value associated with the key E in this dictionary? You'll say, oh, that's pretty easy. I'll write the dictionary name, and in box brackets, I'm going to give you the key. Pass the key that you want me to find the value for, and this thing will evaluate to 5. Pretty simple. Now, if I were to give you something like this, I say, what's that going to be? Python will say, okay, you're telling me to find the value for a key F in this dictionary, so it's going to go through and it's going to try to find the key F. It won't find it, and if it doesn't, you'll get an error. Specifically, you'll get a key error where Python will just say that it wasn't able to find any value associated for this key F in your dictionary. So be on the lookout on that. So then you say, okay, what if I want to add this key and it's some value to my dictionary? Well, okay, we're going to use this template all over again. But instead of just, doing D box bracket F, I'm going to say equals, let's say 9. And now this changes things a little bit. Now Python will say, oh, you're storing somewhere, right? There's an equal sign. So there is a right-hand side and there is a left-hand side. And it notices that you are using a key in a dictionary on the left-hand side. So Python will first do some tests. So it will actually go and test one thing. And what it'll test is, does key F exist? So it'll go through and it'll say, okay, does the key F actually exist here? And if the answer is true, then Python will update its value and replace it with 9. And if it doesn't exist, Python will add a new key value pair. So in dictionaries, you can only add a pair at a time. You can't just add a single key and then add its value later. You have to do it right off the bat. So once this line executes, Python will say, okay, does the key F exist? It doesn't? Cool. I'm just going to add a new one. So it's going to make this modification and then it's just going to add a new pair. It doesn't really matter where F is stored because order isn't a thing here. So no order. It doesn't really matter what the order is because what matters is what the values are associated with. So what the key value pair is. I could have F with 9 over here or over there. If I were to just give me the value associated with F, it'll always just be 9. That's not going to change. So this is what's going to happen after I run this line. And then if I were to do D of H equals 6. So again, Python's going to test this thing out. It's going to say, okay, does the key H exist in my dictionary? And it does. So instead of adding a new key value pair, it is going to update its value. It's going to say, okay, I'm going to update you to 9. And all of this is possible because dictionaries are immutable. All right. Okay. One last thing to add here. I can make dictionaries where the keys and values can be different data types and data structures. By that, I mean something like this. So it's going to look a little bizarre. But I have a key value pair, so I'm going to label them as I go. I have a key and a value pair where the key is a string and a value is a list. All right. And then I will do something like this. This dictionary sort of doesn't make sense, but to bring forth the point, a key and a value again. So now I'm using a tuple as a key and another dictionary as a value. So this dictionary has a dictionary inside of it. So it doesn't really matter what kind of values you're using for what kind of data types you're using or data structures you're using for the values. But for the keys, it is imperative that keys can only be immutable objects. So don't forget that. If I try to make a list as a key, Python will give me an error. It'll just throw an error to me. It'll say I cannot use immutable objects as keys. We've already had a long discussion on how mutable objects behave in memory. And if you were to use them as keys to your dictionary and then modify those keys, because you can modify mutable objects, it's going to give you, it's going to cause a lot of headache to Python. And so it doesn't just allow you to do that right away. Okay. So I'm able to then do things like this thing, right? What I'm saying here is give me the value associated with the key tuple 1, 2, and it'll give me that entire dictionary. And I can chain these commands together. So I know this whole thing. I know that this command in green returns this dictionary. So I can just chain a command on top of it and do something like this. Because this whole thing evaluates to a dictionary, then I'm saying, okay, within that dictionary, give me the value associated to the key B, which is this guy. So this code works, and you'll get hello out at the very end. So in conclusion, let's list out all the features and properties that we now know about dictionaries, and we're going to start off with the fact that they are a data structure, and they are a collection, right? And they're not a sequence, so order really doesn't matter here, just the pair matters. And dictionaries act more like a map than anything. So you will have, you'll say that a key maps to a value, right? Something like this. And searching for values for an associated key is very, very quick. So this is going to provide you an efficient searching mechanisms. We're also going to know that dictionaries are in fact iterable. The indexes don't exist, but I can use them in a for loop. And finally, we'll also, in the next lecture or in class, we'll also look at a set of methods and functions that we can apply on dictionaries.